In the last video, we have studied about binomial expansions of the form x plus y to the power n, which is given here. So in this expression, you can see there are n plus 1 terms for power n. You can see nc0, which is first term, nc1, this is second term, and this is third, nc2 is third. In the same pattern, nc3 is fourth term. Similarly, this is nth term and this is n plus 1th term. So there are n plus 1 terms in the binomial expansion. We will write the general formula of the general term. Let's suppose the general term is tr plus 1. So for the general term tr plus 1, we have to take ncr for r plus 1th term, that is x to the n minus r, y to the r. You can see this is the general term for r here. So for the general r plus 1th term, we have to take ncr. You can see here, this is first term, we have taken nc0. This is second term, we have taken nc1. And I have subtracted 1 from n and I have taken power 1 of y. In the same pattern for the third term t2 plus 1, I will write nc2 and I will subtract 2 from n and I will take power 2 of y. So the general term is given below. Here you can see. So it can be used to find many kind of problems in this situation. So look at the very first example below. In this example, we have to find the coefficient of x to the 4 in the expression of this. You know, this expression has two terms. This is x and this is y. So the general binomial formula is used for x plus y to the n. You can see here x plus y to the n, right? So this is the general binomial formula and we have expanded in this way. In order to compare this formula with x and y, we have to take x is equal to 3, y is equal to negative 2x and n is equal to 7. Here you can compare this thing with this thing. You can see 3 is corresponding to x, minus 2x is corresponding to y, and n is corresponding to 7. Therefore, I have taken n is equal to 7, y is equal to negative 2x, and x is equal to 3. But the problem is that we are not asked to find this expansion in this way, right? So we have to only find the coefficient of x to the 4. So we have to find only one term, not all terms. So what is the general formula to find one term? You can see here I have written down the general formula of r plus 1th term is this. Okay, so the general formula of finding r plus 1th term is this. In this formula, we have to put x is equal to 3, y is equal to negative 2x, and n is equal to 7. So after putting these values, we will get tr plus 1 is the same as 7cr 3 to the n minus r. And what is y? Y is negative 2x plus negative 2x to the power r. So this is the same as ncr 7cr 3 to the 7 minus r plus minus 2 to the power r and x to the power r. So in the question, he has required that we have to find the coefficient of x to the 4. So in this expression, you can see we have x to the r. So we have to put r is equal to 4 because he required that find the coefficient of x to the 4. Therefore, in this expression, we have to put r is equal to 4. So by putting r is equal to 4, here I will get t 4 plus 1 is the same as 7c4. 3 times 7 minus 4 minus 2 times 2 to the 4 and x to the 4. Now we will solve this expression. This is 7 factorial over 4 factorial times 7 minus 4 factorial, and this is 3 to the power 3, and this is 2 to the power 4, because when power is even this negative can be disappeared. So here you have x to the 4. You can expand 7 factorial in this way: 7 times 6 times 5 times 4 factorial. Here you have 4 factorial and 3 factorial. Here you have 3 to the 3, 2 to the 4, x to the 4. This factorial can be cancelled out with this factorial, and 3 factorial is 6. 6 can be cancelled out by 6. You will get 35 times 3 to the 3, 2 to the 4, x to the 4. So you will get 15,120 x to the 4. So the coefficient of x to the 4 is 15,120. So this is done. Look at another example. So in this expression, we have to find the term involving x to the negative 2 in the expression of this binomial expression. So we have to again find only one term, not the whole binomial expression. So we have to find only one term which involves this power of x. So here you can again compare this expression with the general binomial expression, which is x plus y to the n. You can see x corresponds to x, y corresponds to this term, this is negative 2 over x square, and n corresponds to 13, right? So we will replace x by x, y by negative 2 over x square, and n by 13 in this expression, right? So we have to find the term which involves x to the negative 2. You can see here. We will use the general formula of finding general term. So the general formula for finding the general term is tr plus 1 ncr x to the n minus r y to the r. But in our case, our x is replaced by x, y was replaced by minus 2 over x square, and n was replaced by 13. So tr plus 1 is given by 13cr x to the 13 minus r negative 2 over x square to the power r. You can again see I've replaced n by 13 in this expression, x by x in this expression, which is as it is. So this term comes as it is, you can see here. And the second term, y to the r, since we have to replace y by minus 2 over x square, therefore I have written down minus 2 over x square instead of y. So after simplifying, we will get 13cr x to the n minus r minus 2 to the r x to the 2 to the power r. So which is equal to 13cr x to the n minus r minus 2 to the r x to the 2r. Since the base of this and the base of this expression is the same, which is x, so we can sum their powers. So 13cr is as it is, x to the n minus r, and you can take this power to the numerator and we will get x to the minus 2r, and this term as it is, minus 2 to the r. Since the bases of these two terms are same, so we will add their powers. We will get n minus r minus 2r. So minus 2 to the r. So you will get 13cr x to the n minus 3r times minus 2 to the r. Now look what he asked in the questions. Actually, he asked to find the coefficient of x to the minus 2. You can see in the question, he had required that find the term involving x to the minus 2, but here you have x to the n minus 3r. So if I put n minus 3r is equal to minus 2. Sorry, here we have 13 minus 3r, not n minus r, because we had replaced 13 by n. Since we have to find the coefficient of x to the minus 2, so here we have power x to the 13 minus 3r. So in order to find the coefficient of x to the negative 2, we have to put x to the minus 2 is equal to 13 minus 3r. So now take this term here and take this term here. You will get 13 plus 2 is equal to 3r. So you will get 15 is equal to 3r. So here r is equal to 15 by 3. So r is equal to 5. So we have to put r is equal to 5 in the general term. So here is the term, put r is equal to 5, you will get t 5 plus 1, 13c5, x to the 13 minus 3 times 5, minus 2 to the 5. You will get 13c5, x to the 13 minus 15, which is minus 2, minus 2 to the 5. So by definition, 13c5 is 13 factorial over 5 factorial into 3 minus 5 factorial. And here you have minus 2 to the 5 x to the minus 2. So you will get 13 factorial over 5 factorial times 8 factorial. So this is minus 2 to the 5, because power of minus 2 is minus 2 to the 5, because this power is odd, not even. Therefore, you will get negative here. So x to the minus 2. So you will get minus at the start. So after calculations, you will get 41184 x to the minus 2. So this is the term which involves x to the minus 2. So this is our required answer.